On page 47, it says, Joan King is a marketing director for the BurgerRama restaurant chain. And BurgerRama has just decided that they want to produce a cartoon character doll to sell at their restaurants. So the company has a bunch of different versions of the doll that they can choose to use, and they all sell at different prices. And King's problem is, how does she decide which selling price will best suit the needs of BurgerRama's customers and store managers? And so King has this data, this table on page 47, from previous similar promotions, so previous times that they've done something like this, to help her make a decision. So in our table, we have a column that says the selling price of each doll, so how much each version of that doll will sell for. We have a column that says the numbers supplied per week to the store, and a number requested per week per store. What does it mean when we talk about the number supplied? What do we talk about when we talk about supply? How much they have or how much they've made? Yeah, so our supply is how much the merchant has in stock. It's the amount available that they have to sell. If you were selling something, would you want to sell it for a higher price or a lower price to make money? Higher price. So you're more likely to be making these, or you're more likely to have more dolls in stock if you're selling them at a higher price. So that's our supply, is that if we're selling our dolls, we want to be selling more the more it costs. So in our column, as our selling price goes up, the amount that is in the supply is also going up. So number 1 says, use the data from the table above to plot points representing the selling price. That's the first column, the selling price. And the supply price, which we said is our second column. And we want to put that on a graph. It tells us the selling price should appear on the x-axis. So our x values are the selling price. So we can say those are our x's. And the number of dolls per week per store should be on the y-axis. So this second column is our y. Then it says draw a line through the data points and write the word supply on this line. So if we're using the selling price for each doll as our x's, and the y's are our supply number, how can we use the table to plot a line on our graph? That's the question we're asking. First, we have to figure out how we put our axes on this grid, because we don't have anything there, right? Can our price ever be negative? No. Can our number of dolls that we're selling ever be negative? No. So if we can't have negative price and we can't have negative number of dolls, how should I draw my graph if I want it to always be positive? Which part of the graph is that? So if we're looking at a coordinate plane, we have two y and x axes, which part of that plane is only going to be positive?
Right. I don't know what it's called. Isn't it like 1, 2, 3, 4?
Yeah, quadrant 1, or the top right.
Oh, I forgot about that.
So if we know we need to have it always being positive, my graph is going to be just that first quadrant, just that first part. And it told us that our x-axis is going to be our price, and our y-axis is going to be number of dolls. So now I want to figure out what scale I use on my graph.
For X, I just did ones.
So we did ones
Yeah.
for x's. That works. Do we want to do every single line is $1, or how many total dollars do we see in our table?
4.
4. So maybe we want to space it out a little bit more so we can see closer. So I'm going to do about 4 spots. So every 4 squares, I'm going to have $1. And that's helpful too, because now we know that every line is 1/4 of $1, which is 1/4. So what about our y-axis, our number of dolls? How would we want to scale that? Would it make sense to have every line be 1 doll? No, why not?
It's too big.
Yeah, because we have too big of a number. So how else could we graph it? We could have every 20s. We could do every 100s. I'm going to do every 50 because I see we have 35, then 130, and 320. So I know that I'll get my 150, 200. So I'm going to have every line be 50. Which means I'll end up going up to about 800 dolls. Okay, now we have our coordinate plane set up. We have our x's, our price, and our y's are our number of dolls. How do I use the table to graph a line for the number supplied each week? So if this is my supply, I know my price is my x's, and my number of dolls, my y's. So I'm just going to rewrite what it says in the table. I have $1, $2, and $4. And that is the same as $35, $130, and $320. So the table itself is giving me my X and Y values. It's giving exactly what I need to plot the points. So my first pair is $1 and $35. So I'm going to go down and I see I have $1. And if I am looking at my y-axis, $35 will actually be pretty close to my x-axis because we're going up by 50s. Then my next pair of values is $2 and $130. So I'll go to $2 and graph up at $130. Now my next point is at $4, $320. Should be about there. Is that enough to draw a line? Yeah, that's plenty to draw a line. I'm going to remove my table. And I can draw a line all the way through. And the last piece of instructions in that first one says, write the word supply on it. That's the line that represents supply. Anyone else need a ruler? Okay, number 2 says plot the points representing the selling price. So that's still in my first column, that's still selling price. But now we're looking at the number requested. So we said that number supplied, our supply is the amount that the merchant has or the store has to sell. That's the supply. What would the number requested be? We have supply, and what's the opposite of supply? We've talked about this.
Demand.
Demand, yeah. So the number requested is the same as the demand. And in problem 2, it says the number requested, and in parentheses, it tells you that's the demand. So what does the demand represent? The demand is, yeah, the demand is what the customer is buying, what they want to buy. And for demand, would you rather buy something that's cheaper or more expensive? Cheaper. So as the price goes down, the demand for it goes up because people are more likely to buy it. So now we're going to do a similar thing that we did for the supply. We have our X's is our price, $1, $2, and $4. And our Y is going to be the number requested. So my first point is for at $1, the number requested is $530. I go to $1, $530. My second point is at $2, I have 400. And at $4, the demand is $140. So that should be right about there. Just like before, we said 3 points is plenty to make a line, so I can connect those dots. And the last part in that problem says to label it demand.
You seem a little off.
So the $1 is going to be $5.30, so it should be a little bit higher there. Use the ruler. Thank you. This one will be at 400, so that's up. Okay, so we have 2 lines. One is for supply and one is for demand. On the next page, it tells us we're going to use our graph to answer the following questions. Part A says, if Joan King sets the price at $2.50 per doll, how many disappointed customers will each store have during the week? So what are we looking at on our graph? What is our part A asking us to look at? If X is 250. So if King sets the price at 250, we'll look on our x-axis. We have $2 marked. I would go 2 notches up to 250. So that's what we talked about. We had 4 segments in each, so it's every line is a quarter. And at 250, I'm going to draw a line up. So when the price is $2.50, about how much is the demand? You can approximate this. And the price is $2.50. Yeah, so a little bit above 300 and a little below 350. So we can say that point is, Kayla, what'd you say?
Well, mine is smaller, but I said like 340.
340. That seems like a great estimate. And then we can look at where the supply line crosses at 250, and we can approximate that to say that looks a little bit like 170 maybe?
Yeah, put 175.
175, yeah. So if King sets the price at $2.50 per doll, we said that about 340 dolls are demanded. Uh-oh. Yeah, we're good. but 170 dolls are supplied. And the question is, how many disappointed customers will each store have during the week?
Like one, where you subtracted,
So we'll subtract them?
or that's right, is that right?
Yeah, that sounds good. Walk me through why you're subtracting it.
So I know that they have 170 dolls, but there's 340 people that want dolls, so only 170 of them are gonna get dolls, so I subtracted.
Yeah, exactly. So Kayla said 340 dolls are demanded. That's how many the consumers are wanting, but there's only 170. So we subtract the number 340 minus 170. So there would be about 170 disappointed customers. Because we did 340 minus 170. So part B says, if King sets the price at $3.80 per doll, how many unsold dolls will remain at each store at the end of a week? So we went to the graph and we said, now we're looking for $3.80. $3.80 on our graph is going to be just like right before we get to 4, just that line before. And I'll draw my line up so we can actually see it. About there. So at $3.80 for a doll, how much is our supply? It looks like it's, yeah, like 300, maybe just a little bit above. So when the X is 380, we're going to approximate that we have about 310 dolls supplied. And for the demand, looks like it might be just above that line. I'm going to say at 380 we have right about 160 dolls. And that's just an approximation. If you had a little bit different, that's okay. So we looked at where our lines crossed at each X value. So, at $3.80 per doll, there were about 310 dolls supplied. But only around 160 dolls demanded. So how many unsold dolls will remain at each store at the end of a week if our cost is $3.80? How would we figure that out? What's that, Billy? 150? How do we get 150? Yeah, we subtract 310 from and 160. And there would be about 150 dolls left unsold. And this time we did 310 minus 160. Part C says, according to our graph, if the company could give the dolls away, how many would each store need per week? What would it mean if they're giving the dolls away? What's that? Yeah. What would our price be?
Not zero.
Our price would be 0. So if the company is giving the dolls away, means our price is $0. Are we looking at our supply line or our demand one? Demand. Why demand?
Because I know they're giving the dolls away, so how much like the people want.
Yeah, exactly. So if they're giving the dolls away, how many dolls do people want? So we're going to look at demand. And I'm going to hop back to the graph for a second. So we said our price is $0, and we're looking at our demand line. If our price is $0, where should I look? Yeah, the y-axis. We're looking where the demand line's y-intercept is. So that looks like it's right about there. So when our cost is $0,
$6.50.
looks like it might be just above $6.50. I'm going to call it $6.60. $6.50 is right around there too. So we know that if a company is just giving their merchandise away, so $0, that would be our y-intercept of our line. So there's 660 dolls, about 660 dolls demanded when the price is $0. Just like we said, we're looking at the y-axis. We're looking at where that line intercepts the y-axis. So it's the y-intercept of the demand curve line. Part D says, according to our graph, what price would make the doll supply so tight that the average number available to each store would be 0? What does that look like on our graph? Thank you. What am I looking for? the supply is so tight that the average number available to each store would be 0. What do we notice in that question? What is it asking us to find? What is this problem asking us to find?
The price when the doll supply would be 0?
The price when the doll supply would be 0. So I see a lot of keywords in there. I see the doll supply. So I know we're looking at the supply line. The average number would be 0. So we're looking at when the number of dolls is at 0. And then right at the beginning it says, what price? So we know we're looking for the cost. We're looking for the price. So where on the graph would I look if I want to look at the supply line when they have 0 dolls? How much would the dolls cost if we have no dolls at the store?
That would be like less than
Yeah, so I heard 50 cents, less than $1. How do we know? So we're looking at this area, and we said it's going to be less than $1. What did you two look for?
Just
How-
when X was, when Y was 0.
When Y was 0. So our Y is our number of dolls. We're looking for when our number of dolls is 0. So that would be right there. And then because we know we're looking at our supply line, they looked at where that is crossing the x-axis. So I have it really zoomed in on my graph, and it looks like it's pretty close to 50 cents. It's less than $1. Looks like maybe 75 cents. It's kind of in between those two lines. So about 75 cents per doll means that there's no dolls supplied. And if we set it up above that when we had a price of $0, that was our y-intercept, what point on our graph did this represent?
The X intercept.
The x-intercept. So this is the x-intercept of the supply line. So, to look back on what we've done, we basically took this table of values, this data table, we recognized which column represented X's and Y's. We used our data in the table to graph two lines. And then just from that, we've answered all these questions. So we can use the data in our table to make lines that can help us answer our questions. The last part says, estimate the price where supply and demand will be in equilibrium. What does it mean to be in equilibrium? They meet or they're equal? Yeah, so they're equal. Where they meet. What word have we been using when we talk about where two lines are meeting? Oh, it is a solution. It is econ. I'm sure you've talked about this. It's also, our solution is where our two lines intersect, exactly. So we saw that equilibrium, that first part says equa, that means it's the same as, it's equal. We know that a point is equal on both lines where those lines are intersecting. So now we can look back at our graph. We see, where are those two lines intersecting? Where's the equilibrium? Like right in the middle there. That's our equilibrium. About where does that look like it's hitting? What's that?
320, 350.
What were you saying? Okay, so it looks like it's right across there and right down here. So maybe a little bit under $3.25. So we can say maybe $3.20. That's like right below that notch. And what about the number of dolls? Where is this hitting? Looks like it's
40. I put 250, but
250. Yeah, 250. Maybe a little bit below 240. So we could say 240, maybe 245. So we can say at about $3.20, the supply and demand are in equilibrium. And the number of those dolls that are both supplied and demanded at $3.20 is around 245. So we used our table, we made our graphs. Those two graphs, those two lines are maybe a system of linear equations. And then we use that to find a whole bunch of points that tell us about our supply and demand. Tomorrow, since we will not see you, it's an e-learning day. We have an assignment up on Canvas. I will pull up.
So if you click on modules,
Shooting every Thursday.
there you go, and then scroll down to tomorrow.
Okay, so tomorrow you go to our page for that day, February 10th. But on the day, it will tell you pretty much the same information. The link is solving with 2 plus equations. It'll be on page 50. This is the teacher review. And that will be due tomorrow. That is your assignment for e-learning day tomorrow.
While you do get multiple attempts on the assignment, like you do for all the others, the way that you'll get counted present for tomorrow for attendance purposes is that you have at least 1 submission in before midnight tomorrow night, because the office is the one taking attendance tomorrow. So as long as you get in and you submit 1 attempt, you will be counted present for this class. You have multiple attempts, you can go back in and try it again later if you want to, but at least hit submit 1 time before midnight tomorrow. All right, guys?